Okay, welcome to this explainer. We're going to completely reframe how you think about the birth of human knowledge today. When you hear the word science, you probably picture modern laboratories, massive telescopes, or maybe a solitary genius having a sudden eureka moment. But to find the real roots of scientific thought, we actually need to go back thousands of years to the ancient river valleys of Egypt and Mesopotamia. And we need to look not at philosophers, but at administrators. Ask yourself this fundamental question. Why did humans actually invent math and writing in the first place? I mean, you might picture ancient thinkers gazing up at the stars or crafting these beautiful poems to record their myths. But the true catalyst was a lot more practical, a lot less romantic, and honestly, incredibly relatable to our modern lives. The real answer? To collect taxes and count sheep. Seriously, the grand origins of science began, quite simply, because ancient people needed a reliable way to manage their massive agricultural economies. The spark of human genius wasn't born out of abstract pondering. It came from sheer, overwhelming administrative necessity. So today, we're covering 6 main topics: the economics of early science, how writing was basically the first spreadsheet, the birth of mathematics, Egypt's decimal system, Babylon's base 60 breakthrough, and finally, the lasting legacy of all this ancient math. Let's dive right into Section 1, the economics of early science, and how temples acted as ancient corporations. It's so easy to look at majestic ancient temples and just view them strictly as spiritual centers. But in reality, they were the absolute epicenters of ancient economies. The priests and scribes inside weren't just praying all day. They were managing immense agricultural wealth, distributing loans, collecting taxes, and organizing sprawling trade networks. They were essentially the CEOs and chief accountants of the ancient world. To really give you a sense of scale here, check out this staggering number. The Harris Papyrus, which is a famous ancient Egyptian document, records that under Pharaoh Ramses III, a single temple complex owned this jaw-dropping number of cattle, 490,386, plus over 1 million fidans of land. You just simply cannot manage that level of wealth relying solely on human memory. Which brings us naturally to Section 2, writing, or what was essentially the world's first spreadsheet. So, with wealth that massive, priests desperately needed a system. Writing actually evolved in very logical, practical steps to solve this. It definitely didn't start as literature. Step 1 was just using physical signs on sticks for simple tallying. But as the temple economies exploded in size, that wasn't cutting it anymore. So in Step 2, they started drawing simple pictograms on clay tablets, like a quick sketch of a cow or a basket of grain. Finally, in Step 3, as transactions got way more complex, these pictures morphed into abstract, phonetic, and symbolic representations. Writing evolved step by step, strictly as an administrative tool to log incoming grain and outgoing cattle, way before it was ever used for history or poetry. So the absolutely crucial point here is that writing was basically the original spreadsheet. This invention allowed for the standardization of weights and measures, making massive, large-scale trade possible. And maybe more importantly, it created an entirely new specialized social class, the scribes. This was a massive shift, right? It forever separated the intellectual work of the elite scribes inside the temples from the manual labor of the farmers out in the fields. Knowledge officially became a profession. Okay, moving on to Section 3, the birth of mathematics. Because just writing down numbers wasn't enough anymore. They had to actually manipulate those numbers and calculate things. Ancient civilizations hit a massive wall that historians actually call the problem of large numbers. This is the point where basic counting tools completely failed to manage complex, large-scale economic and architectural data. Think about it. When you have to build giant silos to store an entire nation's grain supply or dig massive irrigation canals to feed cities, guessing simply does not work. You can't just eyeball the volume of a massive cylinder. You need precise geometry and volume calculations just to survive. Let's see how different cultures tackled this, starting with Section 4, Egypt's decimal system. The Egyptians came up with a mathematical system that's actually very similar to the base 10 decimal system we use today. They had specific hieroglyphic symbols for 1, 10, 100, and 1,000. But there was a major catch. They didn't have place values. That means to write a number like 879, you couldn't just write down 3 digits. You had to physically draw 8 symbols for 100, 7 symbols for 10, and 9 symbols for 1. That is 24 individual symbols just to write down one single number. It was incredibly repetitive. And to complicate things further, Egyptian mathematics struggles heavily with complex fractions. Because they mostly limited themselves to fractions with a numerator of 1, like a half, a fourth, or an eighth, with a rare exception of 2/3, their progress in abstract mathematics eventually hit a ceiling. To write a fraction like 5/8, they had to break it down and literally write it as 1/2 plus 1/8. This clunky notation made advanced algebra nearly impossible. It was super practical for their daily building and taxing needs, but it just lacked theoretical flexibility. Meanwhile, over in Mesopotamia, they had a totally different idea. Section 5, Babylon's Base 60 Breakthrough. When you compare the two empires side by side, the difference is just wild. While Egypt used those repetitive symbols, Babylon developed a positional base 60 or sexagesimal system. Positional is the absolute magic word here. It meant the placement of a symbol changed its overall value, exactly like how our modern math works, where a 1 can mean 1, 10, or 100 depending on where it sits. This structural shift allowed the Babylonians to perform much faster, way more advanced calculations. Driven by their sprawling trade networks that required constant currency conversions, loan tracking, and interest calculations, the Babylonians basically created advanced computational devices out of clay tablets. They weren't just counting anymore. They developed advanced multiplication and division tables, reciprocal tables, and even solved quadratic and cubic equations. They were literally filling out complex algebra worksheets on clay tablets to speed through their commercial transactions. It's mind-blowing. And this really highlights the incredibly advanced level of Babylonian geometry. They derived mathematical formulas for things like calculating the chord of a circle. They were mapping out complex geometry millennia before modern algebra was formalized. They definitely weren't just recording livestock at this point. They were doing high-level engineering math to manage a booming empire. Which perfectly sets up our final section, the legacy of ancient math. All this practical math, born in the sweat of Egyptian temple construction and the noise of Babylonian markets, laid the direct groundwork for everything that followed. Later Greek thinkers like Pythagoras took these highly practical economic tools and transformed them into abstract theoretical sciences. The Greeks inherited the hard-won data of the ancient scribes and started looking at geometry and numbers, not just to measure fields or calculate grain taxes, but to actually understand the fundamental laws of the physical universe. So the crucial point to take away from this entire explainer is this. Human civilization and scientific thought didn't just progress because some solitary genius was daydreaming in a vacuum. It progressed out of absolute urgent necessity. We learned to write, calculate, and engineer because we desperately needed to survive, trade, and build our societies. And the craziest part? The impact of this ancient administrative work is still with us today, every single second. The 4,000-year-old Babylonian Base 60 system was so incredibly effective and so brilliantly designed for dividing fractions that it outlived the fall of their entire empire. Which perfectly explains why today, thousands of years later, we still divide our hours into 60 minutes, our minutes into 60 seconds, and our circles into 360 degrees. It is a direct, unbroken echo of ancient accountants just doing their daily work. So I want to leave you with this final, provocative thought. Have you looked at your watch lately and realized you are effectively wearing a 4,000-year-old Babylonian tax collection tool right on your wrist? It's absolutely amazing how the mundane administrative chores of the ancient past built the very scientific foundation of our present reality. I leave you with that thought. Until next time, keep questioning the everyday world around you.